Okay, thank you. And welcome everyone. I was supposed to talk about maintaining open source EventStore and working with it in Cashflow management system, but my colleague told me that the presentation title should be like a commit message, so it should be short and it shouldn't contain the and word. So I will rather talk about how we work with the RailsEventStore in Cashflow management system. And by the way, we also maintain this open source EventStore, but this will take less place in the presentation. My name is Łukasz Reszke. I work in Arkansas Consulting Company. We mostly deal with Rails legacy code bases. And in this talk, I'll tell you 8 stories about how we use RailsEventStore in the Trezi. That's the Cashflow management application. So to just give you some context, Cashflow management application, it gathers the data from the banks, and then it calculates how your business is doing. We show some KPIs, we show some graphs. Whether you're green, basically what the most important thing is that if you're green or red. If you're green, it's good to go. If you're red, then you need to start worrying a little bit about how your business is doing. And I mentioned we maintain the RailsEventStore, so let me introduce. It is the open source implementation of EventStore for Ruby and Rails, established in 2014. And it acts as a library responsible for publishing events, consuming them, storing, retrieving, so basically what event stores do. Also, in this presentation, I'll be referring to the combination of event sourcing together with event-driven architecture, because in our case, this brings the most value to the system. It means that the events that are published will also be utilized by some kind of event handlers. So let's start this journey. And I'll start with the first story, which I called the one with the open banking provider. So as I said, in Trezi, the Cashflow management system, it's necessary to get some data, right? We don't get this data from the bank directly because this would be insufficient. So instead, we rely on open banking providers to get the data, and they integrate with banks. It's not our job, we use software as a service. And they send this data to us through webhooks. Are you familiar with what webhook is? Okay, so basically for those who are not, we expose an API, a post endpoint that the open banking provider is hitting. They basically just push the data into our system, okay? And in this example, we'll be dealing with bank account, specifically with bank account balance and transactions that are available in this bank account. So that's the context. And when it comes to processing webhooks, there are at least 2 approaches that one can follow. First is the synchronous processing. So when we get the payload from the open banking provider, we can just pass it like a hot potato through all the layers until it lands in the lovely embrace of the database. But one may ask, what if something goes wrong on the way to the database? For example, what if something fails with processing that data, or when we get the constraint rejected? There's a lot of things that may go wrong there, right? So what if there was another way, and instead we would publish a technical event with the payload, with entire payload that we get from the open banking provider, and then actually process this in a different way, process this asynchronously. So once the open banking provider hits our API, we convert this request, the payload of the request, to technical event. We push it to the queue. We don't do any transformations because we don't want to risk that something will go wrong. And then there will be some event handler that will be, well, interested in that event. And this event handler's responsibility will be getting this data into the database and also doing some transformations. And there are certain benefits in that approach. First of all, we get external system audit log. So we see exactly what kind of payload we received from the external system. We rely on 3 external systems, so this is kind of useful information for us, especially for debugging and troubleshooting. I'll show you some examples in the rest of the stories. We also have improved performance because our responses to the third party are super fast, right? We get this payload, we convert it into technical event, and by converting it, I just mean that we publish it as the data of the event, and then we respond that, hey, we're done, right? So it's super fast, and also our processing of course, it goes to the asynchronously, so we can scale the application independently. We can scale the processing independently from the web server, right? Because we move it to some jobs behind. That's another benefit. And the last one is that we don't rely on the third-party retry mechanism. So if something goes wrong on our side, we can just simply fix the code or just even reply the event to try again, right? We don't have to wait for the external provider to make the decision to kind of send us the same information once again. We really want to have control over this. And this is very helpful, and keep that in mind. It will be very useful in the next stories. However, there is one more thing that we should talk about in this open banking provider context. So as I said, we decided to move the processing of webhooks into async processes, right? And one question pops up in mind. What could possibly go wrong here, right? There's no such a thing as a free lunch. And by getting few awesome benefits, we introduced a problem. And the problem is the fact that webhooks, which are now converted and represented by events, may be handled out of order. And of course, order matters, right? Consider the following situation. When we receive a webhook with, let's say, 100 bank account balance, currency is not important here, and we try to process that webhook, of course, first we publish it as a technical event and we fail processing. When there comes another webhook and we publish it as a technical event and then we process it successfully this time and we start processing the new one, well, we just overwrite the data, right? So the client, our customer, will see incorrect value in the UI. And that's not something that we should do. We shouldn't really overwrite the data. So this is the problem that we introduced. The event order really matters. And it's a good moment to stop for a minute. And I would like to introduce you to, well, what's actually the code architecture. So basically there is no architecture. Trezi is, it's a startup, and I call this code written in a startup way. And there is, for most of the concept in the system, there is just one relational model that represents the entire concept. For example, transaction has 35 columns, bank account has 21, and user, well, that's a big one, there is 43. So I won't fool you, logical coupling is a thing in Trezi. And that is fine, because it did the job, it earned the money, it enabled us to go forward. And however, there's one thing. If we knew at that moment that we need to extend this model, right? We need to add some kind of column or maybe information from when the actual webhook came from what time. And we already know that the bank account, because it was related to the bank account, this model is kind of too big. So it's a good moment to start to divide it to smaller parts. Ideally, the things that we modify in this table should be totally separated from the right model, but we are not yet there. But for this part, we decided to create a separate model. And after a few iterations, we ended with something like this. So this is a class that we have in the code. I will show you that on the next slide. We call it the bank account. Maybe that's not the best name. We'll see why. But it has only one responsibility. So if you can see, there is this external provider timestamp. This is the information that we gather, that we get from each external provider, and then they tell us, okay, this webhook, this information was valid at this date, this timestamp. This information is used in the perform method. So perform operation method is only performed or is only executed correctly if the timestamp is not older than currently applied. We have to respect that rule, and also when the bank account is not closed. This information comes from the status field and is modified by the close method, right? So, as I said, this method is only, this operation can be only performed if those two rules are correct. Then the operation is performed. In Ruby code, and by the way, I don't agree. I think Ruby code is more beautiful than the Go code. Sorry, bro. And you can see that's a very simple code. It has no external dependencies. It has just two methods, and it reacts to the events whenever we load them and we try to retrieve the state, right? We could say it's very easy to test because you can rely on events. but also it's event sourced and it only has one task to do. It has to answer the question whether the operation can be performed or not. Nothing else. We don't know about the balance. We don't really care about the bank account balance. We don't care about transactions. We don't care about anything but this two simple information, whether the bank account is closed or not, and about this external provider timestamp. And that would be at the end of this project, because we didn't really have time to rewrite half of the system. So we introduced that change. We created separate model, and it has to be used somewhere, right? So we decided to write to the aggregate root, to the aggregate, the bank account aggregate, which is in this line. We call this perform operation method in here, together with writing to the read model, which happens, well, this is this waterfall of the code, which actually ends up with the save method. You don't have to read that. Basically, what is important is here, we tell when the operation can be performed. If it cannot be, we throw an exception, and if it's fine to process that webhook, we just go forward and save the data into our database. And what I want to tell you is that it's hard to always be perfect. And this thing was really blocking me previously, and that was one of the reasons why I was kind of scared of introducing event sourcing. And now I understood when I started working with this project that we need to be pragmatic, and it's okay to just do half of the steps and maybe continue later, get to the full pattern eventually if this is needed. But we really need to be pragmatic. And in our case, we decided that stream will tell the truth, because there may be multiple reasons to delete the bank account in a relational table, right? We don't have the context, it's deleted or not. But when there is information in the stream that says bank account is closed, we know why this happened. And also, you can notice that the stream doesn't have any, let's say, restrictions. It's not closed during any period, so there's a question hanging if it's not going to be too long. But we don't worry about that for now. There is no need to optimize this code. If there will be, we'll deal with that. And having this model on board quickly paid off, as I was dealing with a really strange bug. And it leads us to another story, the one with closed bank account and a missing event. So as you remember, we just implemented an aggregate that keeps track of the bank account's state, and it tells us whether we can perform operation or not. So whether we can process the data or not. And imagine following situation: when we receive a webhook, we convert it to technical event, same old story. We try to process it, but this time we fail. And we just keep failing, and the error says that we failed to save the record. So basically, it just cannot go to the database, so the user doesn't see it. It's not used for any calculations. That's really bad. I was dealing with this one. I was like, okay, why? And I checked the stream. I mean, this is what it is for, right? So I used this browser of streams that we have that comes together with RailsEventStore, and I checked that this bank has a couple of operations performed and nothing else happened. So the stream looked okay. So I looked at the code, and I did some static analysis, and I noticed that it passed this aggregate, so it means that the external provider timestamp was okay, the bank account wasn't closed, and it failed here. That's really strange. And did I mention that it only fails for specific bank accounts? Yeah, that's a true story. Best thing to debug ever. So I harnessed the most advanced debugging techniques that every senior developer knows, and I replayed the event. Because I can. I have the payload, right? So I have every means to do that. And it turned out that the read model was deleted, but there was no event for that aggregate. So remember I said that there is multiple reasons to delete that read model. Someone deleted it, but no event. And that's really strange. Because closing the bank account should always go through the aggregate, right? This information should be in stream. And in healthy stream, it looks like this. We see that the bank account was closed and nothing else happens afterwards, because if we get the webhooks, we ignore them, but we usually try to also deregister from external provider. So I took a quick look around the code. It looked fine. The tests weren't broken. I was like, what is going on in this system? And remember, reads and writes were not entirely separated, so there were two different models that you had to remember to use them correctly, right? And it turned out that there was a new feature introduced to close or disable the bank account, but nobody used it. There was actually one unlucky customer that found it in the, it was hidden in the UI, it was really not well thought through. And it was just supposed to block getting new data for the bank account. But instead, it just soft-deleted this bank account, which, well, it means that it's closed and there should be no more calculations. And as I told you, the writes must go through the aggregate. So the fix was quite easy. We had to add this line of the code because still it wasn't enough for us to invest in that kind of feature to actually do it right and completely separate the model. And one may say that it's wrong because you have two sources of truth. And I would say, yeah, you're right. But we made this decision consciously, and we treat the events and the stream as a source of truth. And that's why there was surprise. Someone just probably forgot it during the implementation, and that's why, that's why we were surprised. But I called it as a cost of point in time, because we couldn't afford rewriting half of the system just to introduce this class. It wasn't enough. It wasn't just as important for the business. I told you, this is the startup. We need to make some trade-offs. The pace of the project back then was really fast, so we were focusing on gathering new customers. And this is okay, because the system doesn't have to follow one pattern entirely, at least not from the start. We can get there eventually. We can just, gradually change the system, re-implement it, refactor, and implement the full pattern. But it doesn't have to go right that from the start if this is not important enough for the system, for the business. But bear with me, because this is not the only aggregate that is protecting rules that we have in the system. I'll get to that later on. But first, I want to tell you the story about pending transactions. So having events in the system is very useful, especially when the system is mostly, in a lot of cases, working asynchronously, but it also depends on external banking provider, right? So imagine there is a bug reported by customer, and they said that, guys, we don't have recent transactions, and the bank account balance is kind of not okay. And I'm always like, yeah, sure, they probably went to 7-Eleven, did some shopping, and then went back, and they expected those transactions to be here. That's the case in 90%. But I always check it because we love our customers and we really want to help. So I went into third-party provider, UI console, and I checked it. And I was really surprised because there was a huge delay. There was 2 weeks of unsynced transactions, more than 700 of them, just waiting to be pulled and calculated and to bring something good. But it didn't happen. And I checked that the open banking provider, they were trying to send us those webhooks. And actually, we had them in the stream. And there was some strange error in our monitoring system that everyone tended to ignore, which said failed on saving the record. And like, not again. And first of all, I think, yeah, someone must have broken it. So I started playing the blame game. I did keep blame, but no new changes. So my second thought was, yeah, so probably provider changed the payload and they never told us. And I compared it and it looked healthy. So I didn't really know what's going on, but I had to fix it. So once again, I harnessed the most advanced debugging techniques and I replayed the event. And when I replayed it, it became clear. I found this issue. And let me tell you what was wrong. So one of the banking providers has this feature that they send you transactions which they call pending transactions that are not fully processed on the bank account side, meaning they can change. They can change the description, maybe some decimal points and so on. So the provider requires you to delete those transactions when you get a new batch. And that's what we did. However, those were soft deleted. So, because in Ruby, there is this possibility to modify the code with some extensions. And there is some awesome gem called Act as Paranoid. And it basically makes your all deletes soft deletes. So it was quite easy to fix it once we found it. But first, we wrote a test to confirm that we understand the bug, right? And that's a true story, that's just not the conference talk. I highly encourage you to write a test in event-driven system that uses event sourcing. Then it's easy to fix it because you can see that you can fix the red test, it turns green, so you know you did a good job. you can deploy it. And now normally you would have to wait for the external provider to gently send you a new webhook with the data, but we could just reply it. As I said, this is very beneficial because we have a full control over our system, and then we can make our customers happy quite sooner than normally we would have to. And that's not the only story that I want to tell you about transactions. So now it's the time that I'll tell you about the other rules that I mentioned in relation to the story of a bank account. But first, some context. When I say transaction classification, I mean that if we have some transactions in our account, this is just a table with transactions with traffic car. Are you guys familiar with traffic car in your countries? Basically, this is a car that you can rent for minutes, very popular in Poland. And then each transaction can have a category. So here I say that those are my travel expenses that hopefully DDD EU will cover. And once I classify that manually, here I try to do it manually, I classify the first one, and the rest of those transactions get automatically classified. However, this is cool, but there's one problem with this model. This model is like a blank sheet of paper. It will just basically accept anything that you insert to it because it's DDD at its finest, and I mean that it's database-driven development. So it's just a anemic model, and there is a bunch of if statements around the code. You can, if you remember about them, that's really cool. We appreciate that. But if you forget, some incorrect data will get to the database. And then everyone who worked with fixing the data knows how painful it is to actually make it right. But hey, as I told you, and I really want to emphasize this, it's a startup. And there were trade-offs that were needed in order to get the money, in order to be competitive and so on. But in this case, business came to us and they said, guys, listen, this feature is very, very important and we need to make it right. We cannot allow any mistakes to go into the database. So they found that this is kind of one of the core domains that we have in the system, and that there was a clarification, so we really needed to make it well, and we needed to make it good. So me and my work partner in crime, Szymon, we started quite a large project of making sure those classification processes produce correct results. And we were quite lucky because 1 or 2 weeks before I wrote an exploration test for POC that became a permanent solution, but that was actually related to classifying transactions. So we had a lot of integration tests in place to actually tell us how this works. No surprise that it worked incorrectly because, the test documented that, but we didn't really want to fix it because that wouldn't help us with the current setup. But what I also want to tell you is that without tests, this would be too risky because there was a lot of changes, and with tests we had something that gave us a feedback if the produced results are still correct. Without that, I don't know, we could try, but it's just like Big Bang rewrite. It's very, very risky. So our project, first part, which we thought is the only part, was to respect classification rules. So basically we have a couple of classification methods, but there is some hierarchy. Manual classification is more important than rule classification, which is more important than manual classification, meaning that automatic classification cannot override rule classification. And as I told you, this logic was spread in event handlers. So sometimes it worked because someone wrote a test and actually respected those rules. And sometimes it just went bananas and we had really funny classifications. So it seems like an easy job, right? We have to encapsulate the business rules. So that was the first goal. We gathered this bunch of if statements from the system. We wrote some unit tests for that. And we introduced the aggregate that was actually responsible for that. And as you can see, this code is really simple because all it does, it checks for some condition. Then it also checks for some condition. And if both conditions are fine and they're fulfilled, then we apply event, meaning that we apply it to the aggregate. And somewhere it's also published to the infrastructure and processed by event handlers. Easy to unit test, beautiful to read, at least better than Go. But now we had to fit it into current process. So we could just extend existing tests to see how it's going to behave. And And it's quite easy to do if you're using event sourcing, because you can just make an assertion that the correct streams are available, correct events are available in a stream, right? So let's say if we do manual, if we do automatic then manual classification, we would expect that those two events will be in the stream. So that's very easy. Once we have those assertions, new assertions, of course the test will start to fail, and to pass the test we need to start writing to both sources. And actually, when we do that, the tests are green, this code is really good to go to the production. However, you have to remember one thing. We need some migration event because we already have some transactions that have certain classifications, so we need to kind of backfill this data, and we need to start the life cycle of those aggregates. Because otherwise, once again, everything will go bananas and we will not have proper data. There's a lot of resources on the internet how to do that. It's also available on our blog, auto-promotion, and if you want to read it, then you're welcome. But now we'll move to the read part. So remember, in the bank account story, we stopped when we started writing to both sources, but now we actually wanted to move this forward because business told us that this is very important. Guys, you have more time than you had previously, and we actually need to make it fully right. So with the read part, we had to update the user view, right? We wanted to move these decisions of how to categorize transaction only to the aggregate, and then based on the events, update the read model. So it turned out to be quite simple because we created the event handler that reacted to certain events and then updated the read model. This is how it looks like in the Ruby code. As you can see, for the different event types, we apply different things to the read model, to something that is actually now a read model. And as the last thing, we stream the update to the UI. So using streams, we refresh the user interface so they have this kind of feeling that there is no eventual consistency. Unless the queue is blocked, then we're in trouble. And shortly after, we got this Slack notification that I was very happy about. We sent errors to Slack, but what it says is that it cannot overwrite rule classified transaction category with account classification, meaning that we didn't have test for it, because otherwise we would fix it, but also it means that before we introduced this aggregate, such a things happened in the system. So some of the users, even though they defined some rules, which are more important than automatic classification, were overwritten, and this shouldn't really happen, right? So we were getting a lot of those errors, so it turned out that it wasn't enough. So besides business rules, there are some kind of different rules that describe when these classifications should happen. And let me tell you about one example. So as I told you, banking provider sends us some data, right? So when we process that data, we publish an event saying the bank account has been synced. And then there are a few event handlers that listen to this event. So there is a transaction classifier that classifies them by rules. There is another one, which we call account classifier, and the global one. Those are two automatic ones. And basically what they did previously, they just updated this read-ish model of transaction. And then once they were finished, they rebuilt the cash flow. As you can see, those three event handlers work almost in the same time. And also we rebuilt the cash flow for the 3 times for the same bank account synced event. And this is a picture that is kind of smooth because in reality it looks like this. So there is 3 event handlers that work together and they kind of fight it for resources. We rebuilt 3 cash flow at the times. I don't know. But yeah, we had to improve it, right? So we found this out. We checked our tests. We looked how this aggregate is used in the code. And we thought that we could do something like this. So when the banking provider sent us the webhook and we process it, we could say that, yeah, we processed this bank account data. And then let's classify it by rules, and then by account classifier, and then by global classifier. And when we do that, we can rebuild the cash flow. So, did we just discover a process? Cool. So now we need to implement a process manager. And actually, it turned out there is more than one process. There was 3 of them, and now we are actually implementing the 4th one. But we said, yeah, okay, so let's even source those as well. And why would you do that? Because for us, it seemed clear that if we have certain steps in the process, then we can have a great visibility of what's actually happening in the process, how much time it takes, what kind of data it modified, what's the current state, and so on. But also, I think the best part is that when the business comes to you and they say, hey guys, we need to add another step to the process, for example, that requires knocking to another external provider, we're like, yeah, sure, no problem. It's just one if statement, we need to modify it. It's quite easy. We actually did that last week. And this is how the stream of an aggregate can look like. So once again, you can see that I did some tests here, but I classified this bank account automatically first, this transaction automatically. Then I did it with some rules defined. I could override it easily. And then I did manually classify it. But if I tried to now set the rules on this transaction, it wouldn't be possible, right? Because there is the aggregate protecting this invariant. Also, well, this is pretty cool because now we don't overwrite it unexpectedly. And this is how the example stream of the process may look like. So we can see this is the manual process. This is a simple one because once it's manually classified, it only triggers the automatic classification with which we call account classification. And you can see it's a very simple, you have visibility, what's there. But if there were more steps, also it would be much easier to debug and kind of analyze if we had these crazy event handlers fighting for resources. So there are certain other benefits to that approach, because there is also possibility to learn about the algorithm accuracy, right? So think about following situation. If we classify a transaction automatically and then customer changes it for some reason, we can learn from that because probably we did something wrong, right? We had a couple of situations when the algorithm didn't really produce best results, if I can say that. Also, the business rules are now fully encapsulated, so no mistakes will get into the database, right? And as I told you, I did a couple of times, it's very expensive to fix the data that is already in the database. It's just better to develop a model that will protect those invariants. It saves us time debugging and making things right. But what I really want to emphasize in this case is that this project was really important for the business. It wasn't our development ambition. We didn't need to do it to have a resume saying that I can do process managers. It was because business came to us and said, this is a very important thing and we need to make it right. We cannot have this data incorrect. That's why we decided to first build the write model and then also extend it to the read model and actually decouple those models to have single source of truth and also read model that is updated asynchronously. So we started from the CRUD, added some events on top of it, and then extracted write model and finally added some read model. I called it event-driven CRUD hybrid, but it's not the best name. However, all rights reserved. We'll see, maybe we come up with something better. And if you have a feeling that it was tough to introduce changes in previous story, I will fool you not. It indeed consumed some glucose. It took us about 6 workdays to re-implement this part, but sometimes it's just way easier than that. A couple of months ago, I grabbed a ticket from Trello regarding gathering feedback from users that cancel subscription. So, when they cancel, you pop up a window asking, hey, why do you cancel? Maybe stay with us. And then you gather this feedback, and initially I thought that we should save it into the database. And that's what I thought I will do, that I will just introduce another column in subscription because it has status canceled. And I thought that, I'll just add reason. But then I was like, okay, but why do they need this? So I just went to the business and I asked, hey guys, how are you going to use it? And they said that, well, we don't need any separate page. We just need to get a notification about when the user cancels subscriptions. For now, we just want to ping them. Maybe we can do something for them. Just, salespeople will act on it if it's possible, if we can fix the feedback. And what's the simplest? Can you do Slack notification? Just Slack notification. Nothing else. So when I realized that, I was like, so screw this. I will not extend this subscription table anymore. I will not add another column. I'll just publish an event. that the customer with the feedback, right? So subscription canceled. There is the feedback that I fetch from the UI that came to the controller. And besides the fact that it's easy to notify to the Slack channel because where there's an event handler, we had some infra to communicate with the Slack already, we also get a context. Because this is my test account, so there's nothing fancy, but still, we can see when user canceled the subscription, and we can kind of figure out what happened before. So maybe the user couldn't do something. Maybe we gave them really wrong classification. They think that, yeah, the system is really crappy. Or, you know, a lot of stuff can go wrong. But having this context instead of just snapshot, it helps you a lot if you can use this information. And that's because this doesn't come for free. As you can see here, I have a stream called by tenant ID and tenant ID. This is something that we often do in our clients project. We link all the events to the tenant stream or to the user stream. It's very helpful. And if we need to build some more sophisticated report, you know, fancy thing for the investors or something like that, we have this feedback, right? We can replay those events, we can do some projection, we can do it. It's here in the event store, waiting to be used. We can categorize it, dig into it, whatever. But for now, if they only need notification, it's just as simple as publishing an event, so adding one line of code. And this is how it looks like. It's simple, maybe not so elegant, but still you can get the value out of it. And I mentioned we link things to the tenant stream and to the user stream. And I want to tell you one more story about when it was very useful insight for me. And this story happened in the beginning of my story with event sourcing. And I was debugging something in the system that shouldn't ever happen. So we had a tenant without any user, and user that didn't belong to any tenant. That was really like a free electron in the system. That was weird. And just to give you some more context, when the user leaves the tenant in our system, we have this super service that checks whether the user was the only tenant, if that user belonged only to one tenant, and it was the only tenant, we remove the user account, right? In healthy situation, it looks like this. So when the user leaves the tenant, well, there is nothing else that is happening. However, in this case, that's a little bit strange because the user left the tenant here, but it was still possible to impersonate that user. This user tried to log in. That was really strange, by the way, but because why would you remove your account if you want to keep logging in? I think they just wanted another free subscription. And that was really interesting. But the most interesting thing is the fact that there is an event, but the user account wasn't really removed. Another slide for those that are behind. And luckily for us, as I said, we link all the events to tenant or user stream. And there's one more thing. When the user tried to log in, I tried to log in impersonating that user. They had a really nice error. You have to trust me, this is also polished by a graphic designer because it was just like one long string, one long sentence. So yeah, they could still log in. That's really cool, right? We could see that the user still exists. And it turned out that there is another way to leave the tenant. It didn't follow the process of checking if the user is the only user. So it's basically the same as in the story of the bank account. Someone just forgot to update the code, or the code with that service that checks if the user is the only user came later and someone forgot to update this place. However, my point is that it was quite easy to find because someone published the event. So I could really quickly find this piece of code that was responsible for that and quickly fix it. I think it took me just once I understood what's going on in the stream, it took me like 5 minutes to find it and actually make it right. Either way, it would be really fun to find the root cause. And this leads us to the last story, which I called the one with knowledge about the process. So once again, like 2 or 3 months ago, we got some new requests from the business to implement a new sign-up process. You know, in startups now it's very popular to have a few steps in the sign-up process where we ask you, how did you hear about us, how are you going to use it, who are you, entrepreneur, software developer, and so on. And we thought that, yeah, so let's even source this information as well, right? There's one small trouble because we don't have any user ID or tenant ID, right, up front. But we can deal with that. We can assign some session ID and then map those two with the user. We can rewrite the stream. That's not a problem. But what can we learn? And first, in the beginning, this initiative came from the engineering team. So we thought that, yeah, so if this process is supposed to be better, let's find out if and why people abandon registration and which step takes the most of time. Just two things, very simple. But what we did is what we usually do. We over-communicated what we did. So we told business that, hey guys, we added some events in the registration. Maybe you'll be interested in that. And we are working together for some time already. So they know what are events. And they kind of know what kind of information they can get out of it, that we can build reports from that, notify Slack, and so on. So we didn't have to wait long until they came to us and they were like, yeah, guys, listen, is it possible to add a feature that we will see if someone started registration but never finished? So we'll get some kind of information about that. Like, sure, no problem. And we could add this event email information into the event. I'll scroll that. You know, I'm not sure how it comes with the GDPR. However, we can use that, and the sales can follow up on people that decided to start registration, but for some reason weren't able to finish it. And now I have to admit something. I made up all those stories. No, I'm just kidding. A couple of years ago, when I first learned that there are more important concepts in programming than learning the latest JavaScript framework, things such as CQRS, domain-driven design, event-driven architecture, event sourcing, they kind of got me. And I bought the sales pitch. I really wanted to follow those approaches. I saw a lot of value here. However, when it comes to event sourcing, I was just very reluctant to start it, and I thought that I need to master all the previous ones first. So I needed to master CQRS, event-driven architecture, because eventual consistency, read models, two databases. It really scared me. I was like, no, first I learned DDD, I master DDD, then I do that. And I want to tell you that, and I hope it was visible, that it doesn't have to be that hard to start using event sourcing as a pattern. In Trezi, we rely on well-known components such as monolithic architecture. There's no microservices. There's simple jobs that process the events asynchronously in the background. It's running on the Sidekick, but I also, on the .NET where I worked, I really like nService Bus. And there's a single Postgres database, and nothing else, no fancy tools. I know it's boring, but it brings the value. So don't be afraid of trying it. Don't be afraid of event sourcing. For me, it turned out not to be as complex as I imagined it in the beginning, as I thought that, that I have to learn a lot of stuff. And then and only then I can proceed to this master level and start event sourcing things. I really like combination of event sourcing and event-driven architecture. However, it's a little bit tricky. There's a lot of traps. And if you do it wrong, it can be hell. And as you can see, it's not really hard to do it wrong. You just have to forget that there may be some order that needs to be respected when you implement yet another event handler. Using it where it makes sense will really help you, but besides that, watch out. And watch out for no order guarantee. If you would like to read it about patterns that you can use, it's a great post by one of my colleagues. And when it comes to introducing event sourcing to your project or in your system, I hope that you can see that gradual changes are possible. So you can do it step by step in legacy, startup, or any other big ball of mud that you inherit. And if you ask me, this is the most satisfying work to deal with. However, you have to let yourself to not be perfect from the start, because you're starting from a really harsh place. You go from the CRUD in the system that maybe shouldn't be a CRUD and should have something more sophisticated than a bunch of ifs spread in these services. And just do it step by step, because we need to be pragmatic, and simple, imperfect solution that brings the value for whatever period of time, it is okay. We need to adapt and improve the software to the stage of the business. And believe me, usually they cannot afford perfect system. So let's focus on those important parts and not over-engineer entire thing. Because as I said, the system doesn't have to follow one pattern entirely, at least not from the beginning. Eventually we'll get there and this will be awesome. But before we do that, let's just accept some trade-offs. Event-driven CRUD hybrid is a thing. And remember, there is no silver bullet. We need to be pragmatic. Every tool has constant pros and cons, and it's not like it's very easy to do event sourcing. There are caveats, there are problems that you can stumble upon, but I believe due to such a place as DDD EU, you will learn how to deal with it, and there are traps. And in my presentation description, I asked whether you would jump on a plane if you knew that it's running on your software. So I don't know about the plane yet. I think I will be a little bit scared. But I have no doubts to use RailsEventStore in client's project, and I'm really proud to be a maintainer. You can contribute. Thank you for your attention.